This section examines basic principles of wheel alignment. All wheels of a vehicle must be correctly positioned with the vehicle and with each other for the vehicle to drive and steer properly. A driver should not need to keep manipulating the steering wheel to maintain the vehicle in a straight ahead position on straight level roads. Similarly, little effort should be needed to turn the vehicle into curves or to let it return to the straight ahead position when the curve has been negotiated. Wheels are installed on the suspension units at certain angles to provide for these factors. These angles taken together are called wheel alignment. The factors that affect wheel alignment are camber, caster, steering axis inclination, toe in, toe out, and toe out on turns. This section examines caster. This is the steering axis center line. Seen from the side of the vehicle, it is normally tilted from the vertical. Caster is the angle formed by this line, and a line drawn vertically through the center of the wheel. Backward tilt from the vertical is positive caster. Forward tilt is negative caster. When a vehicle has positive caster, a line drawn through the steering axis center line meets the road surface ahead of the center line of the wheel. The tire contact point is behind the steering axis. When the wheel is turned to the right, the tire contact point is moved to the left of the direction of travel. And similarly for turning to the left. In forward motion, this generates a self-centering force which helps return the wheels to the neutral position when the steering wheel is released. The effects of positive caster can be seen in the motion of this furniture wheel. When it is acted on by a forward-moving force, its pivot point ahead of the wheel ensures the wheel always trails behind. Most cars have positive caster because it makes it easier to travel in a straight line with minimal driver action. But as positive caster increases, more and more effort is needed to turn the steering wheel. A small amount of negative caster reduces the steering effort needed at low speeds, but can make a vehicle wander at high speeds. In all cases, the manufacturer's specifications should be followed. This section examines camber. Camber is viewed from the front of the vehicle, and it is the angle of tilt of the wheel from the vertical. A wheel that leans away from the vertical at the top is said to have positive camber. A wheel that leans towards the vehicle is said to have negative camber. On earlier vehicles with narrow tires with a large diameter, large camber angles were used to bring the center line of tire road contact closer to the steering axis. It also ensured the vehicle weight was carried by the large inner bearing. On modern vehicles, however, tires are wider, but they are generally smaller in diameter, and large camber angles would produce excessive wear on the outer edges of the tires. The amount of camber is now reduced, so that most cars have what is called zero average camber to give long tire life. This is because when a vehicle is in motion, zero camber is difficult to maintain. Changes in running camber can be caused by road irregularities and load variations. This section examines scrub radius. Scrub radius is also known as steering offset and scrub geometry. It is the distance between two imaginary points on the road surface. The point of center contact between the road surface and the tire, and the point where the steering axis center line contacts the road surface. If these two points intersect at the center of the tire, at the road surface, then the scrub radius is 0. If they intersect below the road surface, scrub radius is positive. If they intersect above the road surface, scrub radius is negative. The effective scrub radius, positive or negative, is to provide a turning moment which attempts to turn the wheel away from the central position when the vehicle is in motion. On a rear-wheel drive vehicle with positive scrub radius, the vehicle's forward motion and the friction between the tire and the road causes a force which tends to move the front wheels back. This would cause the wheels to toe out. If it has negative scrub radius, the front wheels again tend to move back, but this time they toe in. On front-wheel drive vehicles, the opposite occurs. Positive scrub radius causes toe in, and negative causes toe out. During braking on any type of drive, if braking effort is greater on one side of the vehicle than the other, positive scrub radius will cause the vehicle to veer towards the side with the greater effort. Negative scrub radius will cause the vehicle to veer away from the side of greatest effort. How much it veers depends on the size of the scrub radius. This is why vehicles with a diagonal split brake system have negative scrub radius built into the steering geometry. If one half of the brake system fails, then the vehicle will tend to pull up in a straight line. Since the offset of the wheel rim determines where the center line of the tire meets the road surface, it is important that the offset is not changed if wheels are being replaced. Changing the rim offset changes the scrub radius, and also the predictability of the vehicle handling if brakes should fail. This section examines steering axis inclination. The axis around which the wheel assembly swivels as it turns to the right or left is called the steering axis. It is formed by drawing a line through the upper and lower pivot points of the suspension assembly. Seen from the front of the car, it is tilted inward. The angle formed between this line and the vertical provides steering axis inclination angles. Steering axis inclination acts with caster to provide a self-centering of the front wheels. When the wheels are in the straight ahead position, the ends of the stub axles are almost horizontal. When the wheels turn to either side, the effective steering axis inclination is to make the ends of the stub axle tend to move downward, but this is prevented by the wheel. The stub axle carrier then must move up, which raises the front of the vehicle. When the steering wheel is released, the mass of the vehicle forces the stub carrier back down, which pushes the wheels back to a central position. With a vertical steering axis, no self-centering would occur. The wheel would pivot on a radius with the steering axis as its center. This would introduce a turning moment on the wheel. Road shocks would be transmitted back to the steering wheel, and steering would be difficult to control. Steering axis inclination brings the pivot point close to the center of the tire contact patch at the road surface. It intersects with the camber line drawn through the tire and the wheel. If these two lines intersect at the center of the tire at the road surface, then the vehicle is said to have zero offset or zero scrub radius. If they intersect below the road surface, then it has positive offset or scrub radius. If they intersect above the road surface, then it has negative offset or scrub radius. The angle between the steering axis inclination and the camber line is called the included angle. It is a diagnostic angle. Since the steering axis inclination is not adjustable, if the camber angle is correct, then the steering axis inclination should also be correct. That is, it should match the specification. This section examines toe in and toe out. When the front of the wheels, as seen from above, are closer together than the rear of the wheels, it is called toe in. The opposite arrangement is called toe out. The static toe setting is designed to compensate for slight wear in steering connections, which may cause the wheels to splay outwards or inwards. This means the wheels will be parallel when the vehicle is in motion, which avoids tire scrub. This section examines toe out on turns. Toe out on turns is the relative toe setting of the front wheels as they turn to left or right. When a vehicle makes a turn, each wheel should rotate with true rolling motion that is free from tire scrub. True rolling motion is only obtained when each wheel is at 90 degrees to a line drawn between the swivel axis and the center of turn. Because the rear wheels are fixed, the center of turn will lie somewhere along the center line of the rear axle, depending on how far the steering wheel is turned from the straight ahead position. To provide true rolling motion, the inner wheel must be turned through a greater angle than the outer wheel. This allows the inner wheel to turn through a smaller turning radius than the outer wheel. This automatically correct alignment is obtained by use of the Ackermann principle and layout. With the steering linkage at the rear of the wheels, the distance across the tie rod ends at the steering arm joints is made shorter than the distance across the steering axis swivels. This forces the inner wheel to turn through a larger angle when the steering is turned. The Ackermann angle is the angle the steering arms make with the swivels on the center line of the vehicle at or near the center of the rear axle. This section examines turning radius. Turning radius is a measure of how small a circle a vehicle can turn around in when the steering wheel is turned to the limit. All vehicles have stops to limit how far the front wheels can turn. In some designs, these stops can be adjusted as part of a wheel alignment. If the stops are incorrectly adjusted, they could allow too large a turning angle, and the steering box can be damaged.